Welcome to this comprehensive tutorial series on advanced road with sewer design using Autodesk Civil 3D 2025. We'll be diving into the details of a real-world project spanning 50 kilometers as seen in this drawing. We have our design profiles for the main road centerline and sewer design given below here. The longer profile views have the design profiles for the main road centerline. At this circle, we have detailed line work showing the various assemblies used in this project, including roads with different layers, widths and features like road drainage. We can start by viewing our sewer design profile, which contains pipes and manhole details. I will zoom at this profile and notice that we have our pipe labels and sewer profile already in our drawing. I can select on this profile, and we have the name as main storm sewer profile view. The parent alignment is main storm water trunk drain as seen in the profile details. We are going to start this course by designing a pipe network for this main storm sewer. We'll design our pipes and structures in plan view, then place them onto this profile view at the corresponding slope and elevations as detailed in our profile view. The pipe size changes diameter from 600 to 900 to 1200 millimeters. Our profile view bands has manhole invert levels which must be designed at specific levels and stations. We'll place manholes in plan view, then reference this profile view to get the manhole invert details. After this video, which is an introduction to the course, we'll first design this sewer, then proceed to advanced roadworks in the other course videos. The main stormwater trunk drain alignment for our sewer can be selected from here. The drawing has the drain alignment and profile already designed through the whole alignment. I will zoom at this region, then pan using the middle mouse button to view the drain alignment. We have the main manholes detailed in red along the drain route. We also have the stormwater drain details given beside the road corridor, which has labels indicating the extents. The drain labels will help us to identify the pipe size and length while placing our pipes and manholes in the pipe network. This drawing contains manholes and road plan detailed as polylines and will be recreating our sewer and road designs with the provided data. The blue manholes have been arrayed at 50 meters interval along the design route. The main stormwater trunk drain alignment represents the pipe route and specific manhole locations for our sewer design. We can identify the manhole detail at station 3+283 from our sewer profile view below. We can look for the profile view that has the chainage of 3+. And you can see the manhole detail in profile at station 3+283 here. The manholes have been detailed as polylines in this drawing, and we have the labels which shows the stations and invert levels. In this course, you'll need to download some extensions and library files from your Autodesk account. I have Infrastructure Parts Editor installed in this computer. This is an essential tool for creating and customizing pipe networks and structures to meet unique project requirements. You can open a catalog to customize a part by selecting, then hit Open. You can use the navigation panel to edit surface or underground structures. The parts editor allows you to define dimensions, connection points, and other properties while creating custom structures. You can edit an assembly or structure from the part family. We'll learn how to create custom manholes and reinforced concrete pipes in our sewer design lesson. After customizing, we'll save the updated catalog and load it into Civil 3D for use in the pipe network. Pipes can be edited from this option. Then select a catalog to edit or create a pipe and hit Open. You can drop at Create Design. Then access Infrastructure Parts Editor extension command from here. We also have the Part Builder command, which is used for customizing and creating pipe network parts to fit our specific project needs. With that said, we can proceed to discuss the other requirements for this advanced road with sewer design tutorial series. We'll utilize the Vehicle Tracking tab to discuss roundabouts and parking tools. Then in the Analyze tab, we'll grade the parking lot using Grading Objects command with separate videos using this drawing file. I will go to Tool Palettes, right-click here, then select All Palettes. Go to Tool Palettes, right-click below here, then long press the drop arrow to access your installed sub-assemblies. I have the UKIE content installed for Civil 3D 2025. I will show you how to download this content from your Autodesk account. We'll use some sub-assemblies from this content pack while defining our road assemblies in the Advanced Roadworks design. This country kit has a collection of sub-assemblies, tools, reports, libraries, catalogs, and templates. We have various predefined junction assemblies that can be used to define intersections. The Road Sections tab can be used when adding lanes. The Microdrainage tab can be utilized in the sewer design when adding example a trench soakaway. Right-click, then select Help to view the sub-assembly details. You can view from here the steps required so as to use the microdrainage sub-assemblies in your sewer design. In our sewer design video, we'll utilize multiple network catalogs and assign them to the main stormwater trunk drain alignment. This ensures compliance with design standards requiring separation between sanitary and stormwater systems. You can scroll to view more details. Then click here to close the dialog. I will briefly switch to my browser to show you how you can download the required extensions and library content for this course. Log into your Autodesk account, then select Civil 3D from your products and services. Select your product version, then download any updates from this tab if required. Go to the Extensions tab. You can access extensions like grading and optimization, then hit download from here. You can also download Infrastructure Parts Editor extension from here. Use the download option to download Civil 3D extensions from your Autodesk Products account. I will scroll up, then go to Libraries tab to access the various country kits available in multiple languages. You can download the UKIE country kit for the Advanced Road Design course so as to follow along as we design this complex project. You can also download other country kits if you come from any of the regions listed in the list here. These country kits open with the region's language when installed. We can switch back to Civil 3D to discuss on the roadway design introduction and features. As earlier noted, this is a real-world project drawing that we'll be utilizing in this course when designing our roads and sewer. I'll pan to a road section that we'll discuss in the upcoming videos. This road section contains details of a traffic separator at both sides of the centerline alignment given as polylines, which we'll use when defining the lens target in our design. In this course, you'll be able to appreciate the capabilities of Civil 3D workflow in a complex real-world project design. In the region ahead, we have line work for our median, which shall be explained from start on how to create an assembly with the median. We'll use these polylines as targets when defining our cross-sections with medians. Go to View tab, drop at Viewport Configuration, then select 2 vertical to have 2 viewports activated on screen. I will set my right viewport to show the road cross-sections which have been detailed at this green circle here. I will zoom into the cross-section details. And here, we have various cross-sections detailed as polylines line work with hatches as seen. Each cross-section has chainage details as per our main road alignment that will guide us when redefining our corridor in the Advanced Roadworks tutorial. This cross-section has a median as a separator as seen at chainage 20 plus 920. From the left viewport, we'll set this polyline as our target when defining our lanes with medians. We'll cover how to use marked point to control assemblies dynamically and creating lanes from a tapered median. At this chainage along our road alignment, we'll mirror the left polyline to have the other half of our median target to this other side of the alignment. This is a real-world project that can help you to understand the assembly creation for the road corridor design. We'll also discuss on code set styles that help us to visualize and annotate corridor components like points, links, and shapes. When designing with medians, marked points are useful for adjusting the corridor shape when lanes taper or expand based on project requirements. We'll discuss how to recreate this corridor with the given features. The road features have been detailed as polylines which can be used or converted to feature lines for design purposes. You can place your cursor above any line to view the layer properties, and that can help you to identify the road features easily in the model. This road project contains various cross-sections which will be discussed in separate videos for a comprehensive understanding on road design. We can proceed to view other cross-section details that we'll utilize in our advanced road from the right viewport. Each cross-section will have its own assembly defined, and will use the parameters like lane width and material thickness from these details. We can pan above to view more project details. Later in this course, we can recreate this area to have a viaduct section as seen in this view on screen. We can switch to the other viewport to view more details at this drawing area. We have various polylines at the weighbridge section that can be used to create alignments at this area. We have drainage details designed in green that represents the culverts. You can download this drawing file to follow along in this course from my Patreon page, and you can find the link in the description box below. This is our first video for this year, and I would like to wish all the channel subscribers a happy new year and to say that I am grateful for the support. You can support my work by subscribing to my Patreon page, and you'll instantly get access to all working files used in the channel videos. We have regions that require widening along the corridor as seen. This line represents the edge of travel way for our lane, and this other line is for the shoulder. Code set styles can be modified from the tool space palette, then settings tab to have our corridor visualization as detailed in this design. From this widening end, the road transitions back to fixed lanes with. We'll utilize corridor regions to define different road sections along the corridor baseline, and also adjust region boundaries for smooth transitions. Once you download this working file, you'll notice that we have cross-section details placed beside the corridor for ease in creating the various assemblies required to design this 50-kilometer road. We have crossing structures at some stations which will be demonstrated. So kindly get to download this drawing as we'll use it throughout various videos as our main working file. The project settings have been properly defined, and we can go to Geolocation tab to activate Esri Maps so as to confirm if our project location is well georeferenced. This is a highway project located at the coastal area in my country, as you can see. Our alignment route follows the map, and this shows that the coordinate system has been defined correctly. Civil 3D provides a powerful toolset for integrating real-world geographic data into your design projects. Geolocation tab allows us to set coordinate systems, define project locations, incorporate online maps, and manage geospatial data seamlessly. The plots have been digitized and matches the geolocation features like these water boundary details. We'll start this course with the sewer design, then proceed with the advanced road design from the top going down. I will close the map to discuss other details from here. Then select Map Off. We can go to Tool Space Palette. Then expand surfaces. The drawing has referenced surfaces which we unfortunately don't have. We can, however, design both our sewer and road using the drawing profiles provided below. In the sewer design profile view, we have the profile surface data which can be selected when designing the sewer and road corridor. This other profile view has the road design profile and surface data as seen. In Toolspace Palette, if we expand the related surface data, we have no data. We'll design our sewer and corridor using the provided profile views. We have numerous alignments defined in the drawing for the centerline alignments. I will save this file as it is, then upload it in my Patreon page without editing the alignments naming. We also have offset alignments defined and curb return alignments as seen. I will proceed to pipe networks, expand networks, then main storm sewer. Right-click on a network name, then select Network Properties. We'll edit this network when designing our sewer design. We also have other pipe networks in the design like culverts and outfall drain. This course will elevate your design skills, and by having this drawing, you can be able to follow along as we design this project step by step. This video is an introduction to advanced roadworks and sewer design from a real-world project. In case you are watching this channel for the first time, please take a second or two. Hit the subscribe button so that YouTube automatically notifies you when I upload the next video. And to the subscribers, I want to thank you all for the continued support, because without that support, this channel cannot be where it is. Kindly go to my Patreon page to download this and every other working files from the channel. Thanks for watching. See you in the next video.